we're just getting a few more chairs in. Hey everyone, welcome to our monthly, well, at least we're trying to get monthly, Melbourne Python Meetup. So I see a lot of familiar faces today. I see a lot of new faces as well, and it's just great to see how quickly and how big the Python community continues growing, and month after month. And it's great that you guys pretty much all chose to pretty much come down here. I was actually really thinking that with the Anzac Day, surely there might be actually a bit of, some people like taking leave or else. So it's really great to see everyone here just eager to learn more and really here to be able to just listen to all the great talks and yeah, just like chat with more like-minded folks. So again, pretty much just introducing myself to anyone new to the meetup. I'm Rinaldi. I'm the organizer for this meetup. Right now, I'm here also joined by my fellow organizer Kai as well, who's helping out as well with the meetup. And yeah, we're here pretty much to bring you this experience and pretty much just more or less talk about just introduce this meetup for a bit and before handing over to our great speakers for tonight. So let me just do a quick welcome to country. So I'd like to pretty much start off by acknowledging the traditional custodians of the land on which we meet today and pay my respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islanders people here today. So we have a code of conduct at the meetup. So pretty much code of conduct is, in general, just be respectful. It's basically the shortened version of this spiel, and pretty much just not gonna read everything, but if you want to learn more about the code of conduct, you can just go to the link over there, which we have in that MelPy repository. So where's Melbourne Python on the web right now? We're mostly based in 2 different social medias, and you can also pretty much follow the meetup page as well to keep up to date with everything that's going on with Melbourne Python. And that should keep you up to date with all the upcoming events and everything that's gonna come through. But aside from that, you can also connect with Melbourne Python on LinkedIn as well, which is from Melbourne Python User Group, or our Mastodon as well at melpy@mastodon.social. So the agenda today pretty much is starting off with introductions, which I'm doing right now. After that, I'm going to pass on to Dean O'Reilly from AWS, who will be talking about GenAI and its use cases as a Python developer. We're going to take a quick break and have a short message from Lily from PyCon 2024 and do a bit of a break for more food and drinks. And after that, 7 p.m., we'll pick up with Ned Letcher, who will be talking about DuckDB, which is a fast and versatile analytical database to keep in your data toolkit. We'll then move on to closing and continue networking after that, and with doors closing at 8 p.m. So without further ado, now I'd like to start off by acknowledging and giving a big thank you for our sponsors who pretty much we really can't do this without. We have Judo Bank, who's provided with this beautiful venue, and you'll even see it's even more beautiful pretty much with this projector screen like out of the way. You'll be able to see a really great view from here. But yeah, aside from that, we couldn't have been able to meet this place without them. AWS and just digital people who's been helping us as well with the food and drinks. So yeah, to start things off, I'd just like to call on Michael to say a few words for Judo Bank.
Thanks, Rinaldi. Yeah, welcome everyone. It's great to see a few familiar faces, and welcome to anyone who's here new. If you don't know Judo Bank is an SME bank who is bringing back the spirit of relational banking and aims to be the most trusted SME bank in Australia. Yeah, I'd also like to do a shout out to our JDB friends who have helped us host this event. Yeah, thank you. Just a bit of housekeeping. If you need, toilets are down the end to past the elevators to your right, and if you can all have your help at keeping this place clean, that would be Fantastic. Thank you. Have a nice evening.
Thanks, Michael. And next, I'd just like to call on James to say a few words for JDP as well, before we kick the show off.
Yeah, cheers, Benali. Yeah, very quick one. Obviously, thanks to Judo back for hosting, AWS as well, and we have just come aboard to keep your thirst quenched during these meetups. So thanks very much for coming down. Just to introduce people, are recruiters. So we specialize in everything, obviously software engineering, data engineering. So if you are hiring or looking to be hired, come see the big ginger guy or one of the guys in the team, Eva, Alex, or Megan. Cheers.
Thanks, James. And with that, just like to also give a small notice to our Slack. So Slack is pretty much where we keep everyone up to date. You might already be in it, but for everyone new, pretty much this is where all the discussion happens. As you can see, we have a few channels over there, announcements, general, volunteers, so a lot of things pretty much. So if you want to join in and want to stay in the know of what's happening within the meetup, do scan the QR code. That should give you an invitation to join the Slack channel. So I'm just gonna pretty much just let it stay here for about 5 more seconds. But yeah, I know it's always a tough ask to pretty much like have it always aboard. But look, I'm gonna put this at the end of the meetup as well. So if you do not manage to join it or have any problems joining it, yeah, feel free to come to me and yeah, we can pretty much get you signed into the Slack group. And finally, before we start off the sessions, just like to give a in terms of the DevOps pipeline that's being used there.
So the first kind of use case is the code assistant tool. So that's where we're able to introduce GenAI directly into the editor. So we can introduce an extension like GitHub Copilot or Amazon Code Whisperer, which is our version of it, directly into your editor to give you those prompts when coding to speed up that development cycle. So out of the box, it just give a good kind of sample and to what you're, you can comment or even define definition or the kind of name of your function, and it'll give you some prompts in terms of how to get started, in terms of boilerplate, or some recommendations around that. In terms of the Amazon Code Whisperer one, it can also scan hard-to-find vulnerabilities, so identify security vulnerabilities as well, and also flag when code resembles open source or training data, and give you the prompts to identify that in real time. So just to show it in practice, I just installed the Code Whisperer here into my editor, and I'm just writing a simple comment function to create a connection to a MySQL database. And you can see just the prompt coming back to get started. So create the function, and it gives us a prompt to boilerplate code for the actual connector. So it's pretty simple, like use case here, but it does show for those like small tasks, just how fast you can kind of excel, just getting them complete, getting them started. So the second one is just insert the data into the MySQL database, and you can see the insert statement there, also added. And then the final one is just a query that I want. So has anyone played around with any of the code editors? Maybe some hands. Yeah. Well, it's pretty like for those small tasks, like it does speed up like going off. Probably a lot of us go Stack Overflow and check actually when something goes wrong, but we'll just kind of give you that boilerplate approach to just getting started to speed that up. So that's free. You might have to add that as you go to your editor. Yeah, you just leave a comment and it starts generating what kind of identifies what you're looking for. But out of the box, that's great. But the problem that we're seeing now is when we're in business, when we're actually in the workplace, we all have different standards and different frameworks, different libraries. So businesses are now asking, okay, this is great out of the box, but how do we get to link up to our own IP? How do we get like confidence pages or Jira tickets also being returned to the developer during this cycle? So that's where we go into Code Companion. So that's what we're kind of moving into in terms of the space. So some of the functionality is already there in a lot of the solutions out there. So it's asking the question like how do we get the IP, so APIs, code libraries, confidence, all returned during that prompt in the editor. And it's really going to kind of same pathway or way business is asking, how do we connect GTP or the other models directly up into our own data lakes in-house so that we get more relative responses to our business unit users when they're asking those questions. They want the same experience for developers. So how do we give the same kind of response for our own IP directly into the editor for the developers to speed up that software development time? So these are the values there just around code, improving code reusability, reduce the duplicate code, improve the accuracy. So they do this kind of out of the box now, but this is how it works. They all kind of follow the same architecture pattern. So you can see from those who actually started playing around with GenAI, who's played with RAG or understands around like true augmented. So RAG is just the way we can kind of pull in. We look at the documentation up there. That just represents our own IP. So things like our confluence, our repos, our Jira tickets, that's just represented in documents. With RAG, we're able to index that or embed that and kind of store it somewhere that we're able to use it and search it for a GenAI use case like this. So what happens is when the developer asks the question now, prompt me for the same question like a MySQL database, we actually search our internal documentation or our internal repos and find similarities in there, and then actually send the extra data that we just found from our data store along with the prompts to the model then. So we're providing the model to more context of our in-house data stores. So that's how RAG works, and it's basically how a lot of solutions for GenAI are being adopted. And it allows for more retrieval, so we're getting more accurate information back to the developer, and that provides a better response than just out-of-the-box solutions. So we can kind of see this in a simple demo. So in this case, and for more context, when we look at Amazon Bedrock, that's just our service for hosting all these models. So there's a few models in there. But in this case, I'm just asking one of those models, which is the cloud model from a topic, create me a Python program to call the Bedrock service, which hosts these models, and ask it to summarize inputs. And in this case, I'm actually adding the Bedrock API documentation. So in a sense, I'm providing that extra data to allow for more relevant information to be returned here. So I send that off and actually got a good first pass of it. So for anybody who's played around with any of our SDKs, you can see the photo trees, the right library I'm looking for, the right service is being pulled out, defined, and it does give a good pass. It's not 100% accurate, but it does give me that good boilerplate, and it's more accurate to what I'm looking for in the first pass. In contrast, when we actually don't add any documentation and we do the same prompt to the same model, we can see a completely different structure. So we're not getting the accurate response because we're not giving it context. It's just giving me the trend based on the knowledge of the trend with not the actual response I need for my question. So that's where we're going in terms of the code editor, and that's where a lot of businesses are coming in and connecting it to their own internal IP for allowing for that kind of enterprise search for developers. So that's the first use case. Is there any questions on that one before we jump into code understanding? Yeah. Yeah. I think hallucinations will always be an issue, so there will always be like some relevance in terms of testing. In-house, it's adding up, so creating that knowledge base. So with the knowledge base, that's where we absorb in the kind of data lakes or structured and non-structured data, and we index that through embedding, and that's where we can start doing that RAG retrieval augmented generation. So it's connected up. There's a few stages to do it, but it's there. There's a few stages to get to that point. Create a knowledge base is key there, so you're allowing the access to all of that.
Hang on a sec.
So between this augmentation approach and fine-tuning the model directly,
Yeah.
I wonder, have you tried fine-tuning the model?
I don't think it was relevant because we're not looking to retrain the model. We're only providing more context, relevant context to it. So we're seeing that more and more. The RAG approach is actually becoming more and more adopted for use case. There is use cases that fine-tuning is relevant, as opposed to be a specific language, like it's a different language, stuff like that. But in this case, no, this is RAG. So So the next one in terms of the use case is code understanding. So this is getting really interesting where businesses are looking for how can we get the models to understand the code? So infer what the meaning of that code is, what's the code supposed to do. So one interesting use case is around unit testing. So I suppose a lot of people I don't know anyone who actually likes unit testing, but some do. So a lot of businesses are looking at how do we automate that process, right? So to alleviate the pain points of developers. So once we can get to the point where the models can understand the code, we can get the unit tests, code commenting, also improve the code, internal documentation, and also code reviews as well. So that's where a lot of customers are looking to focus on in terms of introducing this technology into their pipeline. And mostly it's really shorten that development time, and also to improve the code reusability and reduce duplication as well. So we're going to look at two scenarios here, or two personas. One being like designers. So think about like a website designer and they want the new functionality and they want the developers to build that functionality. So they go off and they build out Jira ticket and they put a user story in there with some acceptance criteria and tasks for the developer. And they throw it out to the developers and the developers have to kind of try to make sense of actually what they want. So that's the first persona, and the second persona is actually developers. So they get the ticket, try to make sense of it and build something, and then they go off and have several meetings with the designer, go back and forth to actually get something working and actually agreed on. So the first persona is where we introduce the first layer. So looking at the user story, we start off where the designer creates the user story and they submit it to the system. And this is our first interaction with GenAI, being introduced to this kind of DevOps pipeline, or before it even gets to the DevOps pipeline cycle. We can see we're still doing the same thing. So we're doing the RAG, where we're building our knowledge base using design standards, existing user stories, and also our repos. And then we're able to provide that additional context when we're asking these questions. Like, so we get the user story and we say, okay, can you validate this user story? Is there enough detail in the user story for the developer based on what we have context to from the existing user stories? Is there a duplicate? Is there functionality already available for this? And if so, like, send that back to the designer and say this is already complete, or somebody's already working on this. But if not, we can actually then look for relevant existing libraries or existing code to then add to the ticket to then send out to the developers. So you can already see how much time you can save by basically not like checking this before actually even gets to the developer review by just connecting up to our knowledge base. So that's one area that a lot of customers are looking to put this in. When I say customers, I'm talking about developer, engineer needs, where they're looking to try to speed up that development cycle for their engineers. So once we kind of get to a valid, so we say like, okay, there's no duplication, there's no existing functionality. Okay, we can send this over to the development team. But this is where we're actually getting a lot more exciting, and we can see that when we look at CI/CD pipeline in terms of the CI to use integration. We're seeing a lot more adoption or progressive adoption of this technology within that stage of the pipeline. So we can see that like, okay, the developer works on the feature and they commit, right? So it goes to the repo. The first interaction with the model, let's say, is the unit tests. So that's our first interaction. Is there correct coverage, or is there any unit tests at all? If not, we can automate that so we can get the models to understand the code and to produce the first pass of these unit tests. Maybe send it back to the developer to approve and then resubmit. The second one is when we look at code review. So we look at reuse. So of the code, we can check for internal libraries or internal standards and check that and check if it's valid or is there a better way of doing this, and then send that suggestions back to the developer to iterate on that again. So that's our second let's look at increasing our code standard, I suppose, and align to our frameworks. And the third one is going back to that use case when we spoke with the persona around the designer. So here we can actually automate a check from the functionality that we just wrote. Can we check, those from that user story and the acceptance criteria? Are we satisfying that acceptance criteria, right? So instead of having meetings instead of continuous meetings around this, we can actually automate this and send it back to the developer and say, actually, we have a few gaps. It's not fully satisfied. So we can send that back and we'll look at that in the demo next. So that's our third engagement here. And finally, once it's valid, we can generate the comments on release documentation, which is a pain point I imagine a lot of us find when releasing code. So that's where we're again really kind of a lot of customers are exploring here. The one that I didn't add here is when we look at security. So we know that like GenAI is being used or exploited in terms of attack vectors for cross-site scripting and SQL injection. Does everybody know those? So that's just where we're looking for vulnerabilities in the application and the database of the web application even. So we're looking to pass in kind of attack parameters or attack strings to look for those vulnerabilities. So what, in contrast, or what companies are now doing is actually introducing a stage here to allow the models to also do that before we release to try and counter those attacks. So that's another stage here. So just to demonstrate this, in this use case, basically everything is generated by GenAI here. So I basically used a sentence, 2-line sentence. It was just, I wanted to build a new feature for a Flask website, create me a user story and acceptance criteria, and the feature, it needs to have a drop down and select a city and then display the weather for that city. So you can see that the user story actually provided a lot of detail in the first pass. It's quite, like, given what I gave it, there's a lot of detail returned. So then took that story, so that was generated by a Anthropic to Claude model, which is similar to the ChatGPT model. I then took the story and I went off to the Facebook model. Yeah, that one. I'm going to say Lambda. So I went to that model and I said, okay, here's a user story, generate me Python Flask code to achieve this. And it actually gave me a really good pass in first. So there's a lot more code generated here. So what I did, I took the code, I took the user story, and I went to a new version of the Claude model. And I asked it to, provide the user story. Does this section of code solve or address the acceptance criteria, or satisfy the acceptance criteria? And I got like, yes, it does, and the reasons why. So from that stage where we're doing the business validation of the user story, you can see how we can automate that flow, or that stage in the kind of DevOps flow. And we can also see that potential issues were called out as well, so around the API key. So that's easy to be able to flip back down to the developer and say, hey, there's an issue, update this. So we're able to speed up that development cycle by even just this, save a lot of time. So that's the second use case. So any questions on this one? Okay, good. Sure.
Yes. So recovering business analyst here in the previous life. So speaking about requirements and acceptance criteria, spider sense tingling. Have you had any customers going back in time? There was an approach to defining acceptance criteria, cucumber behavior development, given when-thens, where the idea was you would state your requirements, preconditions, event, and then results. And the idea was you'd then essentially write code fixtures that would parse these textual descriptions, and then that would be your tests, particularly in the area of automation testing, UI testing. Have you seen any of that being incorporated?
Not myself. I haven't seen that with my customers. No. So, no.
Okay, could be pretty cool.
Yes.
Hi. Paradoxically, this, I guess, works best on well-written code, right? But that's the code that needs it least. It's easy to look at well-written code and go, this isn't doing what you want it to do. Yeah. It's much more common to look at badly written code and go, what the heck are you trying to do, right? So how does this respond to code that, I guess, is poorly written enough that you can't even answer the question?
I think you just answered your question. So it's bad code, right? So it should be set back. So if it can't understand it, it's identifying potential problems with the code, or can't infer, or just can't understand it, we should be able to identify that, and we should be able to call it out. I haven't tested in that code, but if it is and we can't identify the use case, we should have a test within our pipeline to, manually review and review the comments that came back from it. misvalidated code. I think that's a different problem as well. But yeah, it's a good call out.
Thank you for your great presentation. I have one question. Have you compared other algorithms such as knowledge distillation to, rather than RAG, to compare these two?
I haven't in this demo, no. So this one's just using RAG for this use case, which is most of our customers are adopting this for this use case.
There were any benchmark to use RAG or just based on your experience?
I wouldn't know. For my customers, it's just using RAG, so running benchmarking around that. It's a quite adequate kind of approach to it. It's a faster approach, and I guess to make it operational to achieve business requirements.
Thank you.
There was, I think, one more question.
Hey, just further to this gentleman's question, does it know when it's reading bad code?
I suppose it wouldn't be able to understand. So I suppose if the code was bad and we're asking the user story and I wasn't able to understand the code, so it's bad code, then we'd get no, I wasn't able to satisfy it. So when I did run previous examples, it said no, and this is the reason why. So you can see here we're able to identify the reasons it did. So in contrast, we'll be able to identify the reasons it didn't. If you ran it, yeah, sure. Cool. Yeah, thanks. So the final one's just around application generation. So this is just around like future state. So if we look at, okay, what's next? It's really, well, some avenues or some customers are looking at, okay, how to provide non-technical users the ability to generate that first draft for POC, so proof of concept. And it's really around simple applications. So allowing kind of the business analysts or just non-technical staff be able to generate something quick and easy to kind of show code running, basically, just to show the kind of POC or speed of that POC code cycle. It's really simple applications with no code, so basic web pages, generate reports example. But for this one, if we take what we just did, where we got the user story, we asked the model to generate the code. It's basically what the architecture is: just iterate on that, run the code, see if you get errors, and go through it again. And that's the architecture for this. It's not ideal, and it's not sophisticated, and it's not designed for like sophisticated applications. We do have to break it up into specific features to actually achieve something functional. But it is kind of getting there. It's getting a bit better, but it's not really designed for complex application development. It's really more for that kind of front end data visualization, which we'll just see something demo of as well. But it's really for that kind of front end visualization kind of use cases or proof of concepts. But that's really where some customers are experimenting with, allowing for their non-technical staff to get something operational. But it's very early days in these regards. One way to demo it, so I went back to that Anthropic model. This is the prompt: create me a Flask application. So Flask being the web application framework for Python, and random population data and GDP data from the years 2000 to 2009, and display this on 3 random graphs, so pi, line, a bar graph using Plotly. So those who don't know Plotly, it's just a data visualization library for Python. And then I also include API references. So going back to our first talk around including kind of more context, I gave just the Plotly framework docs and also the Flask framework docs. So I was able to consume or provide me a more accurate response. So I sent that off to Claude, and you can see in terms of the first pass that came back, it was quite actually what I wanted from what the definition or the prompt was. So it's giving me the right libraries, it's giving me the randomization, and it's also giving me the HTML reference as well, along with the graph plotting. So when I install the libraries and get running, actually did give me what I wanted. So it gave me the 3 graphs with random data and displaying. So that's basically where we're at with kind of these demos or these kind of functionality. It isn't quite a simple use case. I don't think it'll get too sophisticated anytime soon, but this kind of demonstrates the art of possible really for the final use case. Great. I think I'm just actually on time. So. Is there any questions on the final use case?
I have a question.
Yeah.
Not so much on the final use case, but just
in general. So I've played around a bit with these things, and as a senior developer, I always find them a bit lacking. And I'm spending just as much time verifying and checking that what's generated is correct as I would have done to just write it myself in the first place. So I guess, do you know what is that something you sort of see in other senior developers or people having a similar experience, or something which I am maybe not doing correctly when I'm doing, because I hear all the time, oh, productivity increase, it's amazing. And then I try it and it's like, no, this is slowing me down. And maybe one day it's going to be fast enough, but at the moment, I feel that maybe if you're a junior developer, you're getting a lot out of it, but if you're a senior developer, it's kind of pulling you down. Is there anything you can speak to in that?
Yeah, I think it depends. So going back to the first example where we have those code editor add-ons, so the extensions, and we're having the editor prompt us. Well, out of the box, it is very simple and kind of use cases. It's trained on data, but it doesn't have the context for what you're asking for unless you connect it open to your internal repo. So it has more context that's relevant for your question. So if you wanted your internal frameworks, your internal patterns to be returned rather than just open source or kind of general data, that's where we kind of see those pain points being resolved. So adding more context or using that RAD kind of solution, connecting it to your knowledge base is how you kind of alleviate those pain points.
Thanks.
In the interest of time, I might ask everyone to hold their questions for now if there's anyone else who wants to ask a question. But yeah, if you want to, so we're going to head into a break after this, but if you want to ask some more questions, please feel free to approach Pete directly as well. I'm sure you're taking more questions as well. But yeah, with that, I think we'll close off the first talk. But thank you again, Dean, and let's everyone give a lot of applause to Dean. So now we're going to take a quick short break, but before we do, as mentioned before, I'd just like to invite Lily to give a few words regarding PyCon 2024. Floor is yours, Lily.
Yeah, I think we got this. Cool. And Nick. I brought Nick. Nick has the shirt. I don't have the shirt. Hello. No, you don't. That's on purpose. Hi. Yeah, so we're running a conference this year. It'll be in Melbourne, November 22nd to 26th. So that's all the other way up the other end of the year. We're giving you a lot of advance notice now because we would really love people to start thinking about talks. If you would like to speak at the event, our call for proposals and so on will open in a month or so. But right now we have a call for specialist tracks open. So our conference is 5 days long. There is a specialist track day on the Friday where we typically have 3 or 4 tracks dedicated to a single topic each. In previous years, we've had things like data, education, DjangoCon has been one of them. We've had tracks on MicroPython in previous years, lots of different things where for that one day, that's a whole track worth of talks on that one topic. You get to sort of dive deep and go into it. The second and third days of the conference are across the weekend, and they're the main event, where we have keynotes, we have lots of different talks from different folks about many aspects of Python and its uses. We're looking at it in software context, in data context, in scientific and research context, all kinds of places where you find it. We want that kind of stuff on our stage. Then the 4th and the 5th days, the Monday and the Tuesday are typically the sprints. And those are days where you can come along, spend some time working on an open source project with the maintainers who are usually there in person. It's a great way to get started with an open source project in Python if you've never done it before. A lot of people make their first pull requests to open source projects in sprints. It's pretty cool. None of these are mandatory days. Some people attend only the Friday, some people attend the main conference only, some people attend the whole thing. But what we really want at the moment is proposals for specialist tracks. And that means that if you have a topic that you're particularly interested in, you think, oh, I would really love to curate a whole day's worth of talks around this and run it at an event where there's going to be a lot of people who are interested in Python coming along, then we want to hear from you. All of the details for the event are at pycon.org.au. So it's pycon.org.au. Rinaldi asked me if I wanted a QR code, and I was like, I think it's okay. We're good. And you can also follow us, there are links on that page, but you can also follow us on Twitter if you're still there. Mastodon, I just migrated our server from Fostodon, we're now self-hosted. Woo! So you can follow us there. I think we're on LinkedIn as well. Yeah. Cool. Yes, so with that, oh, and you know, this is the shirt from last year's event, which was in Adelaide. This year, it will be in Melbourne, so you don't have to go very far. And we would love to hear from you. So pycon.org.au. Yes. Oh, you actually, all right. I will give you the microphone. Be careful.
She's made a grave mistake. My name's Nick. I'm the sponsors coordinator for PyCon AU. I did it last year. I'm doing it again this year. If your organization is looking for skilled developers, hopefully that's a lot of you. We have a lot of them come to our conference. So if you want to get your name in front of people, sponsoring PyCon AU is a great way to do it. If your organization sells something that lots of developers would like to use, we have a lot of people there who might like to buy it, but they might not know about it yet. So whether you are someone who has the authority to go and make sponsorship decisions, or whether you know someone in your organization that is in that position, I would really appreciate if you could have those conversations now. We are working on a prospectus, but certainly I am very easily accessible. So please do start to think about that, and towards the end of, it is almost the end of this month. At the end of this month, we'll have a formal document that you can start to spread around the organization and have a conversation.
Thank you for giving me the mic back. Yeah, pycon.org.au. It's happening in November 22nd to 26th. It's going to be in Melbourne. Thank you.
All right, so we're gonna kick off with our second talk for the night. And so the talk is gonna be DuckDB, fast and versatile analytical database to keep in your data toolkit, which will be delivered by Ned. So a bit about Ned. Ned is a lead data science engineer at ThoughtWorks Australia. He's worked across a range of sectors and domains, applying machine learning, NLP, and data analysis and visualization to business challenges and opportunities. Ned has used his experiences to develop strategies for making effective use of data and AI for identifying and framing the business value of data science and analytics initiatives. Alongside co-author Simon Albury, Ned is writing the book Getting Started with DuckDB, published by PAC, expected to be released around May 2024. So without further ado, let's give a hand together for Ned.
Well, thanks, Melody. Probably not May, in the middle of the year, let's say. Thanks so much for having me, everyone. Looking forward to speaking to you. First of all, who has heard about DuckDB? Yeah, cool. Who's used it? Got a few hands. Okay, cool. Well, is anyone excited by it? Who's used it? Yeah, cool. All right. So I'm going to hopefully get more of you excited by it tonight. Why, even if you don't necessarily have a use case for it right now, why it's just good, I think, to be aware of it and have it, in your data toolkit. So I think I've had a pretty good intro from Rinaldi. As we are in a post-GenAI era, there's my GenAI avatar riding a duck with an extra leg. Okay, so what is all the fuss about DuckDB? GitHub stars are not necessarily a good indicator of popularity or value of a library, but the acceleration, the growth there is quite notable, and I think it does speak to the fact that people are getting excited by this. So I noticed that and played around with it, got excited by it. Simon Aubrey, who used to work with me at ThoughtWorks, said, "Hey, do you want to write a book about it?" And I was like, "Sure, why not?" Which is a choice. So that's coming out very soon. It will definitely be finished revisions by Sunday because I've got a deadline. So anyway, let's jump on in. So what is DuckDB? This is how it was described previously on the DuckDB project. How it is currently described. DuckDB is a fast in-process analytical database. The previous description is a little bit harder to sort of process, so I can see why they changed it, but it actually does a really good job of capturing everything that it does. So I'm just going to quickly run you through it from right to left, what this acronym SOUP means. So DuckDB is an in-process OLAP SQL DB mess. So DBMS, that is a database management system. So remember that a database is not just the thing that processes the data. Well, more than a database, the actual management system part, that is where you've got a bit of software that's actually helping users use it. You know, you've got this sort of like transaction management, and you get ACID compliance, so you're not going to have corrupted entries and things like that, and helping make it to be a useful tool. So it's more than just data processing and getting stuff into a database. It's a fully fledged database management system. SQL, I think everyone here probably has an idea what SQL is. Structured query language. It's been around for quite some time, getting increasingly popular as a way to query and manipulate data. It's sort of in a way, you know, almost like the sort of lingua franca of data. Now, not everyone here might be super into SQL. It's worth calling out that DuckDB's primary interface is SQL, or DuckDB SQL variant, which is very similar to Postgres. It's not the only way to use it. So if you're not super into SQL and you'd rather not learn, there are other ways to use it, and I'll talk to that soon. Okay, so OLAP, has anyone heard the term OLAP before? This one's getting a little bit more niche. So what about OLTP? You heard that term? Yeah, okay, cool. So that OLTP is online transactional processing. And this is where you're talking about your Postgres, your MySQLs, like lots of records, all row-oriented. We've got lots of reads and writes, so lots of web databases and log management. This is not that. This is in contrast to that OLAP, online analytical processing. This is where we want to do things like analytical applications require lots of counting up columns of metrics and numbers and summing them, and grouping by, and then getting the sum of how many products are sold in a certain region. So you're doing big crunching of numbers and sometimes joining as well. It turns out if you try to get a OLTP database to do that, it falls over because it's not designed to do that. Even down to the hardware, we need to make sure that things are stored contiguously on disk. If you're doing row-based, you want to store the rows next to each other. But if we're doing column-based OLAP, we're going to optimize it. So each number, as you scan down to do a sum or an average, average or whatever it is, you can just scan down those columns, vectorized operations. So that's OLAP. In process, has anyone heard of SQLite? Got a few hands here. So SQLite, and if you haven't, that's fine. We're talking about an in-process database. It runs in the process that you're using. So if you're writing a Python application, you can just go import SQLite or import, in this case, DuckDB. And it means that rather than having to go off and query a external application like Postgres or MySQL or whatever it is, where you might have to authenticate, it's just running on the same machine inside the same process, which makes using it dead simple. You don't have to sort of go work out the credentials or let alone stand it up and configure it, which is a whole thing if you've done that before. Right, so yeah, let's just dig into that a little bit more. Some of these things we've mentioned, we've got the dimensions of OLTP and OLAP, in process and standalone. So let's go through them quickly. Which do we see? This is helping us situate where DuckDB lives in the world of databases. In process, it runs inside on the one machine. You don't have to connect to a remote server. And it's OLTP, so row-based. We can't really do analytical stuff easily. Standalone, still OLTP, still row-based, not going to work for analytics, but you have to go and connect to a remote server. So this is where you've got Postgres, MySQL, SQL Server, things like that. Now let's move into the world of analytics that we're interested here. If it's a standalone server, this is where you have your Snowflakes and your BigQuery and Redshift and Pinner and Druid, and there's actually a whole bunch more. I could probably keep on adding things in there, but that's enough. What we're talking about is when it's in process and OLAP. So you can just install it on your local machine, and it works well with analytical data. And it may not be your local machine, it could also be an instance running in the cloud, where you can get a bit more beef, processing power, but it's in a single instance is the way to think about it. When I first started writing this book, DuckDB was the only in-process OLAP database that existed. Since then, we now have CHDB, which is actually the sort of in-process version of ClickHouse. So if you've used that before, it's sort of the equivalent version. I think I haven't used it. I know that it has a bunch of useful features. One big thing is that I believe it only has a Python client, where, as we'll see later, DuckDB has a whole host of different clients, so you can use it with different languages. Okay, so, and it's open source. It's MIT licensed, so it works for a lot of different use cases, commercial or otherwise. And the DuckDB Foundation has it in their clause charter somewhere that it shall always be MIT license, which is kind of cool, I think. So you might have seen there was a whole bunch of different OLAP databases. Why do we need another one? Well, let me talk you through some of the features of DuckDB and why I think there's utility in having another one. So in terms of things that you might use it for, and I guess the call out of this slide is that it can be hard to sort of explain the value of it because it's so versatile. It does different things for different use cases. So one is data analysis. So you can think about using it for something like pandas, polars in Python, or dplyr in R. So you've got some data, you want to go, do some munge it, sort of analyze it, process it, and do something with it. You can use DuckDB for that. We can also use it for data pipelines. It was really DuckDB was more designed for data scientists to give them scalable data processing with DBMS, like good database management solutions that they wouldn't have necessarily otherwise had access to. But then it turns out that a bunch of data engineers and infrastructure folk went, hang on, we can build scalable, analytical, lean pipelines and things. And so you can use it for some of the things you might use Spark, Flink, Hadoop. I've listed open source ones, but there's also a bunch of vendor-based services. I'll sort of talk to the limits. Like, it's not going to scale in the same way as more distributed processing things, but we'll get to that shortly. Data lake querying, this is really cool. You can basically have a DuckDB database running locally, and you can query a whole bunch of data that's sitting on S3, so stored in Parquet, partitioned in Hive format, and it does all of the things that you would expect a tool like that to do, like Trino, Presto, Amazon Athena. You've got predicate pushdown, where it's like if you don't need a certain column, don't pull that back from the Parquet file. Or if you don't need stuff from a different partition, don't pull it back. So you're getting all these optimizations with minimal transfer over the wire. Heaps more to say about these things, but I'm just going through them quickly. Data warehousing. Before DuckDB, there wasn't really a good, this is my take, someone yell out if you disagree. There wasn't really a good sort of open source data warehouse solution. DuckDB is, it's still lightweight. It's not going to compete at the scale with these things. But if you've got a smaller amount of data, and a good sort of heuristic people talk to is about sort of 1 to 2 terabytes. I mean, probably more. It really just depends on your access patterns and latency and things like that. What your workloads are, but if you just need to do like a lot of business intelligence reporting, that we're not talking about big data. You could actually off a decent instance, you could run a data warehouse, have dbt sit on top of it. So it's actually a viable solution for that. Data queue. So this is again kind of similar to data warehousing, but data warehousing doesn't work so well for low latency response time. So if you want to plug it into a data app where you need sort of embedded reporting of lots of sort of high throughput event data, you need really responsive interfaces to get your queries back from your app. This is what these databases give you. You're not going to get those sort of low latency response times from these more data warehouse style things. Again, for the right set of data, you could use DuckDB for that and plug it into different web apps to build more custom sort of, whether it's business intelligence or sort of custom decision support tools. Data apps, and I guess that's sort of similar to what I was talking about. But if you're a data scientist, you can sort of plug DuckDB into Streamlit, Plotly, Shiny if you prefer R. But that's Python things here. Also, really cool. DuckDB has a WASM client, so it can run entirely in the browser. Which means you can just actually build a full HTML and JavaScript client-based web app using DuckDB running its compute, its analytical processing in the web browser. Okay, so that was speed running a lot of the features. I've forgotten what's next. Types of DuckDB use cases. So broadly speaking, there are really broadly speaking, two sort of ways to think about using DuckDB. One is scaling and supercharging data science, data analytics, and ad hoc data wrangling workflows. You've got some data, you're sitting there in your machine, you want to analyze it. DuckDB is really useful for that. It'll help you process more data than you can fit into something like pandas. So a whole bunch of useful features that do it faster. It'll process more data with less memory. If you run out of memory, it can do out-of-core processing. It'll spill over to disk. Get yourself a fast sort of NVMe drive, and it'll still perform pretty well. Basically, it sort of really kind of feels like you're redefining what big data is for someone like a data scientist or a data analyst who's like, oh no, I need to go get a Spark cluster. I don't have one, or what do I do now? Or it's not in that. This will sort of either able to solve those problems in front of you, or kick that can down the road, and like you can just do more on with less compute. And the other sort of application is a bit of a building block for operational infrastructure and interactive data products. So a lot of those use cases I was talking about on the previous slide, data pipelines, data warehousing, actually building out dashboards and business intelligence things. So, okay, and then next slide is, I guess these are some sort of examples of tweets that, when people are like, I just don't understand, why is DuckDB, like, I don't quite get it. These are some things you might see people talking about. And often you really have to sit down and play with it and go, it lets me do these kinds of things. And I need to add to, I keep on popping into tweets or, posts like this. They sort of happen most of the time. I guess, that's from a blog post. People are getting excited about it. I think these are a lot of the things I've talked about already. What have I not talked about? Portability, has no external dependencies, DuckDB core. So it actually means that you can compile it into a whole bunch of different target languages and runtimes. So, whether it's Rust, it's built in C++, but because of the fact that it doesn't have any external dependencies, you can get it there. There's Python wrappers, TypeScript, Node wrappers. We'll get to the clients later. There's a whole bunch of them. And there are extensions for it. And I think I've spoken about some of these other things. And it's open source. When DuckDB is perhaps not the right tool, if you have an OLTP workload, if you've got lots of data that the access patterns are really, row-based, record-oriented, lots of reads and writes, DuckDB is better at lots of reading. If you're writing lots of records, individual records or groups of them, it can do it, but it won't do it as well. And if you want to in-process OLTP, then SQLite. That's the way to go, use that. But if you've got like really big scale data, like more than a bunch of terabytes, and again, it does depend on what the workload is, so I can't sort of give you like an absolute cutoff there. But at a certain point, you do need a distributed data processing engine. But it's worth giving it a go and saying, hey, maybe I can solve this problem with this one. I was going to jump into DuckDB is SQL flavored. It has its own SQL dialect, similar to Postgres. It has a bunch of cool, friendly SQL enhancements. I won't go through this because not everyone here is going to be sort of necessarily going to be excited by them as much. If you do know SQL well and are looking for sort of improvements over sort of friction points with SQL, have a look at these links. I will post these slides in the Slack, which Rinaldi was talking about before, after this. And we might see one of these in a sec when I jump into a hands-on demo, which I think is next. No, we're going to talk about the Python client. But before I do that, I've spoken a lot about DuckDB, where it sits in the landscape. I might open the floor to any questions. Does anyone have any questions about everything I've said, like where DuckDB sits and how it compares? No? Okay, cool. Moving on. I'll open up for more questions in a bit. If you've got any more, hold on to them. So, the Python client. We are at a Python meetup. You might want to use Python with DuckDB. Here's some ways you can use it. There's two APIs. Well, there's a few APIs, but there's two sort of core ones that you might be interested in. This is kind of the really interesting one if you're doing analytical stuff. It's a specific API that DuckDB has come up with for the Python client, and it revolves around using relation objects to represent SQL queries. The really cool thing about it is that they're lazily executed. So we'll see this in a second. You can compose queries which kind of represent SQL query components. You can join them together. You can sort of pull from them as though it's like a pipeline. And so it makes it really useful for interactive data analysis. You can just peek at the first few rows rather than having to hydrate, materialize the whole thing. Really cool. There's also the DB API, which if you played around with databases in Python, you'll be familiar with. It's a sort of a standard for trying to, make it so you don't have to know the different APIs of different databases like Postgres, MySQL, SQL Server. You can connect to DuckDB using it. It's, I guess, like there are, things to be aware of. If you use it, it's eager execution. When you call that execute, it will just actually submit the query to DuckDB and your results will be materialized straight away, as opposed to this lazy execution. So in general, unless you need to use the DB API, I'd suggest using the relational API. You might want to use the DB API when you're looking to integrate DuckDB into a library that needs to communicate with other Python, a Python library that needs to communicate with other databases. So there's that interop factor, and that's the whole purpose of the DB API. And you might be looking at using something like SQL Alchemy, which further improves the compatibility across different databases. So I think, oh yeah, and there's a Spark API as well. It's experimental, it's not, kind of doesn't cover every bit about Spark yet, but the cool thing about that is you can run PySpark queries against DuckDB as the engine. So it's basically you're just using DuckDB as if you're writing SQL or whatever other queries, but it's running it against DuckDB. You're querying with PySpark shaped queries, which means if you've got a sort of workloads that are Spark based and you need to sort of run them in production, but hey, you want to run some tests, maybe you could use DuckDB to evaluate them, like to run your tests in continuous integration and things like that. So it's not finished, but I think it's getting there, and so it's ready to try out. But some interesting use cases for kind of like local lightweight running of Spark queries. Okay, so we're going to have a look at a query because I've spoken a lot about DuckDB in the abstract, and maybe it'd be nice to sort of play around with it a bit more hands-on. So we're going to have a look at the Melbourne bike share data set. Does anyone remember the Melbourne bike share? If you're a few years back, the blue ones that had the little pods around Melbourne. No, I don't think they went in the river so much. That was the orange ones. Yeah, this is pre-orange. This is the blue ones. You have to have a little key on your fob. Like, yeah.
You get helmets from 7-Eleven.
Yes, helmets from 7-Eleven. I wonder why it didn't work. So I've downloaded the data set from the Melbourne data portal, Melbourne City Council's data portal. It's about a 900 meg CSV with, I think, 5.6 million records. So it's not humongous, but it's a decent sized data set. So it's a good one to sort of put some different tools through its paces. So we're going to start by loading this with pandas just to sort of, now I know not everyone here will use pandas, but I think it's a good comparison to like if you didn't have something like DuckDB, you'd probably use pandas or polars. It would look pretty similar. Oh, hang on. Let's show you the data set. Here it is. Whoa. Hang on. So this is the CSV, just rendered as sort of tabular representation. We've got the name of the stations and a bunch of different other fields. Run date is the date that the sensor reading. So these are sensor readings, like how many bikes were in a pod, how many bike slots were not filled, and things like that. You might have noticed that, well, you probably didn't, but if you look now at the run date, it's actually just stored as a sort of a series of numbers, which is a date. You can see there's years, then months. So we're going to need to parse that. In pandas, you tell it the date format, and you say, hey, apply that to the run date field, and you read the CSV. Let's do it. We're also going to time it. And that took us, trying to work out how I full screen. The keyboard is not. There we go. That took us 10 seconds. We can see that we uploaded a bit over 5.6 million records. And these are the types that it's come back with. And so, yay, we converted that number-looking thing into a date type. So that's with pandas. What if we want to do it with DuckDB? Oh, hang on, let's have a look at the 3 records. There we go. We've got a data frame, pandas data frame with those records. How might we do this with DuckDB? Step 1, we're going to import DuckDB, and then we're going to create a new connection to a DuckDB database. If this file didn't already exist, it will create a new on-disk DuckDB database. The databases for DuckDB can be either in memory or on disk. Just because it's in process, it's running within the process you're in. Sometimes people might say in memory, and that could be confusing because you actually can have an in-memory database. So it's ephemeral. When you turn the process down, you'll lose your data. This way, when we close the process and make sure we close the connection, everything we write to the database will be persisted. So we'll create ourselves a connection to, I think I already have this created, but if you didn't, that will create that DuckDB file on disk. It's a DuckDB specific file format. And then we're going to run, it looks pretty similar to the query before, in a sense, like you can see the features, but it is a SQL query. So we're saying select star, get all of the columns from, so rather than a table, it's a table function. It returns something that will act like a table. That's the read CSV function. And then we give it the parameters we want. And so it looks pretty similar. We're saying, hey, timestamp format, and then we want to apply the timestamp type to the run date column. So let's run that. And what you'll notice is that ran instantly. So quickly, it's not quite that DuckDB is that fast. It is, you'll see that it is faster than pandas. But the reason it's so fast is we didn't run it. Remember that the relation objects are lazy. So we've just created a relation object that represents that DuckDB query. So what happens when we run it? That was also pretty quick, a little bit longer if you were paying close attention. What you'll see is that it's only pulled out the first 10,000 records. And so this is a feature of the laziness of these relation objects. And it makes them really good for doing analytical work because you probably don't want to materialize the full result just to see, well, hang on, did I load it correctly? In this case, we want to make sure, did the, well, we can't see it here because it's been truncated, but did the run date column get the right type? We don't want to pull down the whole thing just to see that. So that shows you the laziness. Let's check that we did load it right. To do that, I'll run another query. And so we're just using the SQL method of the connection object, which, as you'd imagine, takes a string containing a SQL query. So we're saying, let's get the name, the run date column from relation. Now, this one is really interesting. Where is that relation coming from? Normally, you'd be thinking that's a table in the DuckDB database. If it doesn't find it there, it does what's called a replacement scan. And we say, is there another identifier somewhere in the Python global scope? Yes, there is. It's the relation object. And it's going to pull from that. So we can actually pull from the relation object as if it were a table. And this is where, if you start to think about that, we can compose pipelines of lazily evaluated relation objects. So let's run that. Oh, and one other thing. You might typically, if you're in SQL, go, well, we don't want everything. We just want to get the first few. So you might throw a limit 10 or whatever. Let's, like in pandas, you do head 10. DuckDB has a cool feature using sample. It will randomly select the number that we've asked for, which can be useful because, well, it's not necessarily the first 10 because SQL is inherently not ordered, but just by quirk of how the data is, you might get 10 records that are next to each other that are not representative of the whole data set. So it can be a good practice to randomly pull out the amount you want to look at just to make sure you're sampling from across the whole data set, which is obviously, like in data science, a really relevant thing to be thinking about, and other analytical applications. So we can see here from these two columns, we successfully got the run date column as a timestamp date type, which is what we wanted. So that's great. We haven't actually done kind of the same thing we did in pandas yet. I'm going a bit more in detail through this to sort of show you the features, but what we did before in pandas was create a data frame. So far we've just got that relation object just sitting there. So let's kind of do the equivalent, like pull it down, materialize it into something that will sort of persist in a sense. And here we're going to create a table that has the contents of our relation query once it's all pulled through. So we'll create, or replace if it doesn't exist, a table called bikes as simply the result of selecting everything from our relation. Cool thing about DuckDB, if you are doing select star, we can actually just drop that. It's the same thing. So often, rather than having select star from blah, blah, you can just do from thing, which is nice. And we're timing this. This is the sort of the comparison point here. That was 3.96 seconds. So before it was about 10. So, like a noticeable speed up. So just to give you a sense of, there's way better comparisons in terms of speed, but I think that's just a bit of an indicative sense. So that's kind of comparing it to pandas. If, some of the challenges of what we're looking at here, like, hey, maybe it would be nice to have SQL syntax highlighting. There's a cool library called GPySQL. I won't go through the details, but once I can point in the direction of where to look at the docs and how to set it up. But basically here we're saying, hey, that cell with the magic there, SQL, this is going to be interpreted as a SQL query. Here we've configured it to use our DuckDB connection to the on this database. And we're saving it as a pandas data frame because we turn that there. And so when we run that, where there's a data frame, which is what we've done is counted up the number of readings by name, year, and month together. And if we're interested, Dean mentioned before the Plotly library, we could plot that. And it's not a particularly exciting plot, but you can see that by year, the sensor readings, so 2015, there wasn't any before April. That's obviously when it came online, and maybe it had some issues later on when it didn't exist. And maybe in 2016, there was a problem around August. But yeah, so that's just a bit of an example of using DuckDB in action. I will quickly return to the slides because we just about hit end of time, but I just want to quickly show you a couple more things about just the versatility of DuckDB. So, we can query from, you saw that I queried from a relation. You can actually do select star from a pandas data frame, a polars data frame, an NumPy array. We can read CSV files like we just saw, same with JSON, Parquet, even Excel. And then out the other end, we can export to a whole bunch of things. We can actually, all those files, we can read them from HTTP endpoints if it's hosted. And this is how it's the case that you can do your data lake query. It has support for the S3 API. So whether that CSV file was hosted on by some web server, this is where we give you the data set. DuckDB can just pull down directly from read CSV, or maybe it's on S3 and you have credentials. If you have the right credentials, you could actually write it to an S3 bucket or other cloud storage bucket that's S3 compatible. There's a whole bunch of details there, which, if you want to ask me later, I can talk through more things. We can connect to both pull from and write to some of our OLTP databases through extensions. So, we can actually get around some of the slowness of doing analytics in, say, Postgres by importing from. We're actually, as if we're querying from live, and it'll pull the data through. Take a bit of time to get there, but once it's in, we can now do analytical stuff much more quickly, and you will get speed ups. I did not write that joke. That was ChatGPT. Just for the record. I said before that because DuckDB has no third-party dependencies, the extensions do. That's why they're extensions. The core doesn't. It means that we have official clients in C, C++, Java, Julia, Node, Python, Rust, WebAssembly, and other things, which I don't have time to go through all of them. What that means is we have this amazingly rich ecosystem of consumers, open source libraries, as well as vendor services querying from them. So if there's anything on there that you're interested in talking about more, come and chat to me later. I'm going to keep speeding through DuckDB extensions. Oh, look, these are some of the extensions that, some of them are sort of a bit more core, and they're just sort of like, that enables reading from writing to S3 and HTTP endpoints, but there is a geospatial library, full text search, and just recently a vector search library, which is obviously pretty hot for enabling a lot of the sort of RAG apps and things that Dean was talking about. I am going to wrap up. I think everything else is just, everything else I had before is talking through that original first slide. I'll go back all the way to the start. The original first slide I had where we have all these different use cases. The rest of the talk I have is going into more details about these different sort of scenarios. So if we have time for questions, maybe ask me about the one that interests you the most, and I can jump to the slide. But I think maybe that's probably time for me. And yeah, thanks for listening to my talk.
Thanks so much, Ned, for your talk. So unfortunately, we are a bit out of time, so unfortunately we can't take questions. But again, we'll have a short brief period of time, pretty much before we have to close up the door. So if you have any questions, please do approach Ned, and I'm sure he's happy to take any questions. But aside from that, I'm just going to quickly close up. So as I mentioned before, just gonna more or less briefly leave this page up pretty much after finishing this. But again, just want to give another encouragement to if you're interested, pretty much to get involved with the meetup. As you can see, it's a great community, great people, and great conversations going on. Definitely reach out to me. Happy to pretty much like talk you more through any of these particular things, whether you be if you speak. We're always looking for speakers. We really value each and every one's your talks, and pretty much always happy to hear what your thoughts are as well on different topics. So yeah, feel free to reach out to me. Happy to point you pretty much in where you need to be able to speak as well. So if you're interested in that, feel free to come to me after this as well, after this meetup. And aside from that, if you're interested in volunteering, do come to me as well, and same with sponsoring as well. So yeah, with that, I'd just like to close up. Again, thank you to our big thank you to our sponsors, AWS, Bank, JDP for all their support and throughout this meetup, who made this possible. Couldn't have been possible otherwise. And thank you all for coming to this meetup, and looking forward to seeing you in the next month's meetup. Thank you all.